In this video, I'll show you how to set up a degree wheel and use a dial indicator to find true top dead center. And I have done another video in the past about setting up a degree wheel using a piston stop to find true top dead center. So please check that out if that's the method that you're interested in. But again, this one will focus on a dial or digital indicator. You will notice I have a scooter engine here. That's what I'm going to be working on. But please don't tune out just because you've got, I don't know, a small block Ford or a 4-cylinder Honda. It's a pretty much universal process to find top dead center on most engines. Just some of the actual bits and pieces will vary a little bit. I'm not actually going to show you much detail about installing the degree wheel onto your engine because this is going to vary greatly depending on your application. For me, with a scooter, I've made up this little adapter here that goes over my crankshaft threads and is machined the proper size to fit inside of my degree wheel. And then I've got just another washer that goes over that. And then I put on the nut, which is actually the variator nut in this case, and kind of loosely install that. That way I can still move it around as needed. But again, that part you're going to have to kind of research based on your application because it'll be slightly different depending on what you're working on. One thing that I do want to quickly note here, just in case you're in the market for a degree wheel, you don't own one yet, and you're considering your options, I like to use the biggest degree wheel I can. This is a pretty large degree wheel to be mounted on a scooter. This would be a more typical degree wheel for a scooter. But the larger the diameter of the degree wheel, the more accurate you can be with your measurements, and I'll show you why. So here are my two degree wheels side by side, and you should be able to easily see now that the graduations on the larger diameter degree wheel are further apart than using the smaller diameter degree wheel. So if you imagine a timing pointer trying to indicate exactly where you are on either one of these, there's a larger difference between each degree, and you can be really accurate that way using a larger wheel. And this is an 11-inch wheel here, and this one is, I think, 6.5 to 7-inch wheel. And if you're looking for automotive stuff where you've got plenty of room to spare, I think you can go 2 feet diameter basically, or maybe even larger than that. So get the largest wheel that's practical to you if you're going to use it very much, especially. The next thing you're going to need is some sort of timing pointer. And I keep it simple. This is just a bent up paper clip, I believe. Just something that you can bolt on and point to your degree wheel so you know exactly where you are. In this case, I think it was just a paper clip. You can use welding wire, mechanics wire, all sorts of stuff like that. You can even make one if you want something more, a little beefier, maybe more permanent. You can make something like this. This was just, I think, like roughly 1/8-inch steel bracket that I made one out of. But whatever it is, the main point is to have something that you can move around a little bit for adjustment. But when you're not trying to move it around, you don't want it to move, so it needs to be something rigid enough to stay put when you're not messing with it. Now my pointer is roughly in place over my degree wheel, but it's just randomly placed as far as where it's pointed because I'm nowhere near top dead center. So what I've done is I've taken out my spark plug, and if you are working on an engine with the cylinder head off, then you can just look at this. But for me, I'm going to stick a, this is just an extension. It can be basically anything that's not going to harm your engine that you're not going to drop in there. I'm going to put that in, and then I can use that to watch and find where top dead center is. So basically, the further this comes out of the cylinder, at the highest point, that's going to be my near top dead center mark. You can see it starts to go back down, so I'm going to back it off. And somewhere around here is roughly top dead center. Again, if you have the head off, just put your piston right at the top of the bore at this point. Right now my engine is roughly around top dead center. And you can see that I'm way off here with my pointer and my degree wheel because I'm something like 152 degrees here. So what I need to do is just back this off a little bit to loosen up my degree wheel so I can move it, and then I'll rotate it around until I'm basically lined up with a 0. And try to tighten that down, leaving it near the 0. And that can take a little bit of work to hold the crankshaft still and get this all lined up roughly there. Once your degree wheel is tight and you're in the ballpark of top dead center, don't grab your degree wheel to move the engine around, to rotate the engine. You'll want to either use a ratchet or something to rotate the engine over by the nut. In my case, I can just reach over to the other side of the engine and grab the flywheel. But if you grab the degree wheel and try to move it that way, there is a possibility that it comes loose and changes how it's set up. So don't grab your degree wheel to rotate the engine from here out. The next step is to find a way to mount your dial indicator so that it will indicate the travel of the piston in the bore. And it won't matter if you've got digital or analog dial indicator, either one of those is fine. Metric, standard, doesn't matter. As long as you know how to read it, it can work just fine. The main thing that you need to remember is that you want to go straight down parallel with the bore. You want to be directly perpendicular with the top of the piston. You don't want to come in at any kind of angle because that does throw your measurements off to some degree. So you want to be able to come down straight at the top of the piston. In my case, I'm very lucky. This engine is easy to set up. I've got a little adapter that I made that allows me to install a dial indicator here right through my spark plug hole, and that goes right straight down to my piston. Some similar engines can't do that because their spark plugs come in at an angle, so it's not an option, but for me, that's how I'm going to do it. What will be more common for those of you with larger engines is something like this, which is essentially just a thick plate that will go across one of your cylinder bores, and it will have some sort of provision to securely attach a dial indicator in that, going straight down into the bore. That way you can check the piston's position that way, and they can bolt on or go on over the studs, or there are even magnetic ones that will just basically stick to iron bores and such. The other really common option is to use a magnetic base like this, and you can set it up in a way that puts your dial indicator again straight up and down the bore to measure the piston's travel that way. If you've got a larger engine, you can probably get this right on top of the bore. It just doesn't work so good when you're working with something small like these scooter engines. Now that my dial indicator is set up on the engine, the next thing that I'm going to do is just rotate the engine over and find the highest point that my dial indicator is at, which should be roughly top dead center, and I'll zero my indicator out at top dead center. So I'm just going to rotate the engine over slowly. You can see my piston going up the bore based on the measurements getting higher and higher. It looks like I went to 9.2 something. I'm going to back off and go at that again. Really slowly here. 9.20, 21. Okay, so it gets to 9.21, so I'm going to get my engine back to 9.21 on that dial indicator. Then I'm going to zero it. So that is roughly top dead center. That's the highest position of the piston in the bore, but that doesn't mean that it's true top dead center. Now, while my indicator is at 0, indicating the highest point of travel in the bore, I'm going to go ahead and move my timing pointer around so that it reflects 0 on my degree wheel. Now I want to give you a little bit of a demonstration just to show you the difference between top dead center and true top dead center. So you can see I've got two cameras running. This is the dial indicator, and it is zeroed on top dead center. The highest point of travel that the piston is at in the bore, it is zeroed on that. And then in this camera, you can see my pointer is dead on the 0 on my degree wheel. So let me rotate the engine over, and you can watch both cameras and see what happens when you rely solely on zeroing this dial indicator as your top dead center. And I'm about a degree off that way. So you can see if I start here, I'm at 0 on my dial indicator, and I'm 1 degree away from top dead center. And then 0, I'm still at 0. I get to 2 degrees after top dead center here. Yeah, so it looks to me like I can make 3 to maybe even close to 3.5 degrees while this dial indicator is still zeroed, I'm seeing 3 to 3.5 degrees of movement on my degree wheel. So that is why true top dead center is different from just finding top dead center with a dial indicator. Now I'm going to show you how to find true top dead center using your dial indicator. What I'm going to do is I'm going to choose a number, a distance for travel on my dial indicator. I'll just say I'll go about 2 millimeters down the bore. So I want to see my dial indicator move to 2.00 millimeters. And we go the normal direction of rotation for the engine until I see 2 millimeters on my dial indicator. A little off, I'll back it up, come back at it, slow as I can. There we go. So now I'm 2 millimeters away from top dead center. And it doesn't have to be 2 millimeters, you can go 3 millimeters, 40 thousandths of an inch, 100 thousandths of an inch, whatever you would prefer. But just pick a measurement, try to go at least, I'd say at least 20 thousandths of an inch, or at least around a half millimeter away from top dead center with this measurement. And I've just moved this while I'm talking, so let me get back to my 2 millimeters. So now I'm 2 millimeters from top dead center. Now I look at my degree wheel and I see that I am 22 degrees after top dead center. I'm 22 degrees from top dead center on this side of the zero. And that's while I'm at 2 millimeters down the bore according to my dial indicator. So what I need to do now is to rotate the engine around. I'm going to stay with the same direction travel until I get to 2 millimeters again on my dial indicator. So rotating around, you can see the pistons going down the bore. Then it should start coming back up the bore before long here. There we go, past 180. I can't measure the full stroke with this dial indicator, so that's why you don't see it change near the bottom. Alright, we're coming back up. So this time again, I'm going to try to stop one more time, 2 millimeters from top dead center, or 2 millimeters from my zero on my dial indicator. Trying to go slow here. Oh, passed it. Let me back up and go at it again. And you can see this is very precise. It's actually pretty hard with this engine to stop right on that mark. With larger engines, you would have more resistance from your rings and such to help it stay still and make it a little harder to turn. There we go. Now it looks like I'm about 22.5 from, maybe 22.25 from zero on the before top dead center side. Let me zoom out here to get you a better shot so you can see what I'm saying. Now that you've got a better shot, you can see that I'm about 22.25 degrees over here on this side of the zero, which as I rotate it is before top dead center. The first time around, when I checked, I was at 22 after top dead center over here. So my gap is between those two, basically, between 22.25 over here and 22 dead on over here. Ideally, if I were set up exactly on true top dead center with my degree wheel set up, then what would happen is I'd see 22 here and 22 here, or 22.25 here and 22.25 here. It would always be the exact same number on either side of zero when I was at that same distance down the bore based on my dial indicator's reading. Basically what happened in this example is I got incredibly lucky and I'm 1/4 degree off, it looks like, or maybe 1/8 degree off. Normally what would happen, it would be more likely that you'd get something like a 30 over here and a 10 over here. So what you do is you take both numbers and add them together. So I got 22.25 plus 22, that's 44.25. You divide that in half to get the average, which is 22 1/8. 1/8 of a degree is way more precise than we probably need to be with anything that we ever do with a degree wheel. but that would be exactly where I should set it. A better example might be to take that 30 I said before and the 10. You add 30 plus 10, you get 40. Divide that by 2, that puts you at 20, and you know you've got to set your pointer to 20 degrees. But for me, it's 22 and an 1/8 degree that I need it set at, which is probably not going to happen. But basically what you would do is just try to move this to exactly where you wanted it to be. So if I wanted to be at, say, 20, I would move my pointer now to 20. And then I should find when I went both ways that I got the exact same reading. I'm going to try to get 22 and an 1/8, but basically it's just going to be 22. I don't think I'm going to get a whole lot closer. Again, I just really lucked out on this one. I'm going to call this 22 and an 1/8. I don't really know that that's 22 and an 1/8. This is where a gigantic degree wheel would pay off if you really wanted to be this accurate. But I'm just going to say that's 22 and an 1/8. And then what I'm going to do is I'm going to rotate the engine around again until I go back to 2 millimeters below top dead center on the other side of the engine and see if I'm at the exact same reading. So there's where I am. I'm going to call that 22 and an 1/8 because I don't know that I'm going to get any closer than that. But it's basically at the same position as far as my eyes can tell as it was when I was on the other side of top dead center at this same point down the bore, at 2 millimeters down the bore. Alright, now for my eyes, I'm right on 0 here on my degree wheel. Again, I'm zeroed on my dial indicator, and I'll show you one more time the difference. As what I would think I should get is about 1.5 degrees in either direction before this dial indicator moves off of 0, but we'll find out. Yeah, there's something like 1.5 degrees either way before I get any kind of reading. So there you go. That's how you find true top dead center using a dial indicator. If you've ever done the positive stop or piston stop method, you'll probably see that this is very similar. In both cases, essentially what you're doing is bouncing around on either side of the 0 and trying to make sure that the number that you reach on both sides is exactly even. And pretty much the same process with that. You're going to add the two numbers together that you get on either side, divide by 2, and then there's the number you need to set your timing pointer at. So it's really not that difficult. Hopefully maybe you've learned something by seeing how much travel there actually is if you're only using a zeroed dial indicator and thinking that's your true top dead center. I have heard before that you cannot find true top dead center accurately using a degree wheel, and the only way to do it is by using a piston stop or a positive stop. And I happen to have a positive stop, piston stop right here. It's not very hard for me to set up on this engine, so I'm going to go ahead and remove my dial indicator setup, and I'm going to replace that with my positive stop. I'm not going to touch anything as far as how my degree wheel is oriented, and we're going to see how that comes out. Now my piston stop is set up, so I'm going to rotate the engine in one direction and see where it stops. Okay, I'll zoom you in. And that looks to me like just shy of 16 degrees. Now I rotate the engine in the opposite direction, and we'll see where it stops this time. Okay, zoom you in one more time. And once again, to me, that looks like just shy of 16 degrees. It looks to me like the piston stop as well as the dial indicator are both effective at finding true top dead center because I got the same result using either one of those methods. If one is off, it can't be by much more than a fraction of a degree, which again is going to be less error than we will probably have just based on where we're seeing the thing, because if you are up here or down here, it's going to show something very different. So that's another point, is make sure you try to always look at this from the exact same angle. So anyway, there's how to set it up with a dial indicator. I've shown you the piston stop as well. Hopefully this has been helpful to you. If it has, please like it, share it, and subscribe for more. Thank you for watching.